Welcome all. Today we are going to discuss what is low delta T syndrome in any HVAC and R system and what are the pros and cons any low delta T syndrome can actually impact the HVAC system. So let's start. So here you can see there is a chiller of 1000-ton capacity wherein it is designed for 10 degree Fahrenheit of delta for 100% of the full load capacity actually. 10 degree Fahrenheit means 12 degree inlet, 12 degree centigrade inlet, and 7 degree centigrade outlet, which means 5 degree centigrade. So if chiller is working at full load for 5 degree centigrade of delta, 10 degree Fahrenheit at full load condition, because of functional issues, if chiller is operating at part load conditions, it is becoming inefficient. So if chiller is functioning at 50% of its capacity, it is becoming more inefficient. Chiller is always better if it is being operated at 100%, 90%, 80%, or up to 70% of its operating load, because at that particular time, specific energy consumption for generating 1 ton of air conditioning is optimum. So kW per TR is much better if chiller is operating between 100% to 70% of its load. Below 70%, it start degrades if it is a normal chiller. Today, if the chiller is also integrated with VFD, at the part load conditions like 50% and all, chiller efficiency goes down. So integrating VFD and all of these things further improves the specific energy consumption at 100, 90, 70% of its load conditions. But 50%, 40% is not really the advisable condition, which means at part load, my chiller is going to consume more energy. So let me explain what is the low delta T syndrome in any HVAC and R system. So here you can see there are two chillers. It is a primary loop, and here it is a secondary loop wherein the loads are available. In the primary loop, there is a primary pump, and in the secondary loop, there is a secondary pump, which is the variable. And in the primary, variability is an option if chiller OEM is really allowing to integrate the VFD. In the normal conditions, it is advisable to operate the primary circuit flow and the secondary circuit flow should be same, or primary should be higher than the secondary circuit. There is a possibility when chiller is working at the full load condition and load is also there at the full load. But during the part load condition, if controls are not proper, which is a primarily reason for low delta T syndrome, the return water temperature is lower than the design temperature. So let's say it is designed for 12 degree inlet and outlet of the chiller should be of 7 degree. If the water which is coming from the AHU is coming at a temperature of 10 degree, which means the delta which was earlier available, 12 minus 7, which was of 5 degree centigrade, now with 10 degree and 7 degree, it has become 3 degree. And which restrict the chiller loading conditions also, which restrict chiller to operate at full capacity, which is called a low delta T syndrome. It results in higher energy consumption in pumps, chiller, and the cooling tower because chiller is operating at a part load conditions like 40%, 50% of its. And here it is most inefficient operating duty points for any chiller. And pumps is also coming at full load conditions because the variability option is there, but the demand is there. Constantly water is being pumped. System is unbalanced and that is creating more issues. It reduces the cooling plant capacity. It happens most of the time. Capacity control and the control walls of the air handling units are the cause of low delta T syndrome in most of the cases. So it is really critical selection and the design of control walls for any HVAC and R applications to ensure the optimum performance of central air conditioning system. So hope you have liked my video. It was really helpful for your clearing the thoughts. What is low delta T syndrome and how it can really help someone to avoid such conditions to become more efficient in terms of HVAC chiller operations. So thank you. Subscribe my channel. See you in our next video. Click on the bell button to get the updates on the next videos. I'm also requesting if somebody is having any issue, they can put their comments, remark in the chat box. I will get the questions and try to respond as soon as possible. Thank you. See you in the next video.